What's up everyone, Gareth here with FCP Euro. Welcome back to another DIY video. Today we're working on a 2012 BMW 328i on the lift behind us. All right, so this F30 328 has the N24 cylinder engine, and as you can see, we have a bunch of parts here on the toolbox. The primary focus today is replacing the Valvetronic actuator or the Valvetronic motor. This is located in the cylinder head, involves removal of quite a bit of components, but in this car's case, the Valvetronic motor has stopped functioning. It's 200,000 mile original part, so we're 11 years of age, made a pretty long life. This is a Generation 3 Valvetronic system. We will share the fault code information in the description below so you can see it for yourself, but we diagnosed it and for sure the Valvetronic motor has simply failed. So we just need to show how to replace it. So we're going to take you through the steps of how to replace a Valvetronic actuator on this N24 cylinder. And with that said, let's talk about some of the tools you need to do this job, and then we'll go ahead and jump right into it. So some of the tools you're going to need, we'll talk about just your standard socket sizes: 11mm, 10mm, 8mm, typical BMW, E18 Torx, E8 Torx, E6 Torx. If you can have deep and shallow, probably going to be a little bit more helpful. A T40 Torx and a T30 Torx. If you have a really stubby T40, it's going to be super useful for the vacuum pump. Along with that, adjustable wrenches for dealing with the Vanos actuator. You also need a 4mm Allen key or really long 4mm Allen socket. Bunch of different pry tools, ratchets, and then on some of the specialty side of things, you will need an injector puller to get the injectors out. That is recommended. I've seen people use different means to do so, but you really want to make sure the injectors are pulled straight out. If you're going to be reusing the injectors, you will need to cut the Teflon seals off. So a cutting tool for those Teflon seals and new compression tools for the Teflon seals are going to be needed as well. If you're installing brand new injectors, which are going to have the new Teflon seals on them, you don't need to worry about that side of it. But with that said, these are the basic tools you need to do this job. So let's go ahead and jump right into it. All right, so we have the F30 here on the lift. Obviously, this is an N20 powered BMW, but what we're going to be working on here today is replacing the Valvetronic actuator on this N24 cylinder. This will be the same process on any N20 powered BMW. Also a very similar process for N55 or S55 powered BMWs. Granted, a little bit of a different situation because you're dealing with additional cylinders. What we have to do in order to gain access here to the Valvetronic actuator, which is deep down inside the cylinder head, is we need to pull the valve cover off, which involves opening up the fuel injection system, removing fuel injectors, taking the injector wells out of the cylinder head, high pressure fuel pumps coming off. We got to take this cowl covering off. There's a lot of pre-prep work that we need to do to get there. What I can say is what you will want to do is disconnect the battery ground in the trunk. Reason being is if the car were to turn on or wake up at some point and the fuel line to the high pressure fuel pump is disconnected, it will spray fuel because it'll prime the pump. So you want to avoid that as much as possible. So I went ahead and disconnect the battery ground. What we're going to do, we're going to start by removing the cowl cover here in the back so we get better access to the entire back side of the engine. And that'll allow us to eventually get the valve cover off. So what we have here is, we have these plastic panels here, 10mm sockets. All you need to turn, they're like quarter turn little encapsulated nuts. So we'll just quarter turn those. And before we take injectors out or anything like that, once we have access to full engine, we will vacuum and air blast the engine bay because we don't want anything obviously falling inside the engine. So we'll remove any debris, any kind of clutter. Try to work as clean as possible on this. On the back side, we also need to remove our little windshield seal here, or the seal here for the cowl cover. This goes to the hood. There's a couple of expanding rivets here in the back side that hold it on. So we just need to pull the head of those out. Another thing to note, depending on the production date of your F30 328, when you take the engine cover off, just be aware that early production cars are going to have a vacuum canister built into that cover. So make sure you disconnect the vacuum lines like so before you pull that cover off, because you'll break these lines and then have to replace them later. That's how the turbocharger wastegate is actuated. So just be aware of that. That's only up to 7 of 2012 production. So you're not going to find too many cars that have that. If you have an electric wastegate car, you don't have to worry about that at all. I will say that's the only variation you really need to be aware of. we have this wire that runs across this gasket, so we'll pull that out, and then we'll pull this gasket off of there. And now from here, we have this V-brace we're gonna have to unbolt. Has an E18 Torx back here at the firewall, and if I recall correctly, I believe it's E14 here at the strut tower, or strut mount. Confirm that in a second. Once the V-brace is out of the way, we'll then be able to remove this sort of secondary cover that goes around the back of the engine that's held in with a bunch of 10mm screws. All right, now we have this secondary cover that goes over the backside of the engine. It's held in with a bunch of 10mm screws, so go ahead and pull those out. We have this power wire that goes across the top of the engine. It's held in over here with a 10mm nut. You don't have to take it off. I prefer to move it out of the way, just because when you're working on the engine, it'll tend to sit on top of things, and I've always found it to be a little bit of an interference. So I'll pull it off and I'll just push it off to the side, and just one extra thing for me to remember to put back together, but I just like this out of the way. It's just my personal preference. That's also why you disconnect the battery when you do this kind of work. All right, so from here, we have access to the top of the engine. I'm gonna start off here by removing our ignition coils. We do need those out of the way. We actually have to remove the injector wells themselves, which are bolted to the cylinder head. So I'm just gonna start here first. Tabs that we flip up, these are also supposed to release the connector for the ignition coil. Sometimes these tabs will bend out and around the little tab on the connector that pushes it out. And if you find that you're pulling this thing up and the connector's not moving, push it back down, put your fingers on the side. I like to come in here with a really big angled pick, pull up, and it'll start to push the connector out, like so. And then from here, these things can be stuck pretty good. So I'll come in here with, again, that same pick tool or flathead screwdriver, and then pull up on the coil like so. Instead of trying to pull up with your hands or put your finger in there, just using leverage to pull them up and out. And if you want to label where it came from, that's fine, but these can go back in any cylinder, so that doesn't really matter. Next up, we're gonna unplug our injectors. So best way to explain this, they're just a little 2-pin connector. You'll be able to see it from this side when you're looking at it. All I do is I just go in with a pick and I open up the lock on the injector. And then once the lock is open, you can pull the connector out. Now, these connectors, this little red grommet, this weather seal, these have been known to deteriorate. And unfortunately, BMW does not sell these connectors separate. However, the connector could be purchased separately. We don't have them here at FC Puro yet, but it's coming soon. Because these things degrade like crazy. So just be careful when you're pulling them out. And once we have the injectors pulled, I'll be able to show you how that connector works a little bit better. But just for now, just trust me when I say, open up the lock on the connector, pull the connector out, everything will go well. And now from here, we can undo our ignition coil grounds. It's just an 8mm nut. There's 2 of them. That's what these little ring terminals are here for. And now from here, we'll also just unplug our Valvetronic actuator. So just 2 little tabs there and pull up. You know, one thing to always look at with this, you can buy this part of the wiring harness separately, fortunately. Just make sure the terminals are in good condition, make sure it's not filled with oil, because obviously if oil is leaking up through the Valvetronic actuator, that's gonna cause potential problems. If oil is leaking up through the Valvetronic actuator, you're gonna have to replace it no matter what. But in the case of oil leaking up through the actuator, which is a rare situation, you are going to have to replace the wiring harness more than likely, because oil can migrate down the engine harness and it could make its way all the way to the DME. So you don't want that. Haven't seen examples of that personally, but I have heard of it being a thing. Just be aware of that. And again, this car has a pneumatic wastegate on it. So we have our little solenoid here that basically controls vacuum flow to the turbocharger wastegate. So we're gonna have to move this out of the way and disconnect it, which is fine. And then while we're at it, we can also unplug our high pressure fuel pump for the fuel quantity compensation valve, whatever you'd like to call it. Just move that out of the way. We have a video actually on these high pressure fuel pumps. There was an update where you have to add a different pigtail harness onto it. So the connector may be different whether you have an early production and the original high pressure fuel pump. So just be aware of that. Quite frankly, the most difficult part of this job could end up being removing the vacuum pump from the back of the engine. Just because there's not a lot of space. I use really tiny T40 torque sockets to get back there. We'll do our best to show you what that looks like, but it's a little tight back there. So early production F30s, like I said, they have the pneumatic wastegate. 2 T30 Torx screws hold the little wastegate solenoid to the valve cover. If you have a later production car with a electronic wastegate, this is not even a talking point for you. And what I'm going to do is I'm just going to let this whole thing just sit in the engine bay like so. I'm going to take the screws, thread them back into the valve cover, just so that I remember later on that that's where it was mounted. I'm going to disconnect the high pressure fuel rail sensor, or high pressure fuel sensor. Has a little release mechanism you'll have to reach behind to get, and then from there I like to take a little pocket screwdriver and push the connector off, just because these don't have a lot of room and it can be kind of stubborn sometimes to get off. I'm just removing everything that is attached to the valve cover right now, and then really the last thing we have to do before we can start removing major components is we have our O2 sensors back here. And what I like to do with these is before I disconnect any of them, I'll take 2 zip ties. I'll zip tie one side, where the male connector is, and I'll zip tie the back side of the female side of the connector. And that way later on when I plug this back in, I have a quick and easy reference to identify which one goes where. Usually O2 sensors will be keyed differently, so you can't plug them in incorrectly, but I don't really like to take that chance and find out later on that they are the same connector. And especially when the plugs are really right next to each other, it's pretty easy to potentially mix them up later on. So, breadcrumbs. What you have to do when you work on stuff from time to time, just leave yourself clues. I've also done this before with fuel systems, if there's a return and a feed hose next to each other, and you never know how long it's gonna be until you come back on a project sometimes. So it's just, why even worry about having to guess when you could just give yourself a visual identifier as to what goes where. And again, if you ever have to take something apart in the future, you leave those zip ties in place and you have your little clue for later on. So it's a trick I've used for a long time, and it removes a lot of guesswork or potential guesswork later on. So for these O2 sensors, you have 2 locks. You have one on the male connector, so you just basically press up on it. And then the way that this interface is, you have these tabs on the side that you'll also want to push at the same time to pull them off. So it's got like a 2-lock system, which there's not a lot of room to work with, but as long as you're pushing the locks, you'll be able to disconnect them pretty easily. All right, now we're gonna go ahead and crack our high pressure fuel system here. I like to take a rag and cover whatever fitting I am loosening first. I'm gonna come here at the high pressure fuel pump. So I'm looking at our feed up to the high pressure fuel rail. The other reason why I want to disconnect the battery is we don't want the fuel system to ever be able to prime while we have this open. So this is just more of a safety thing. And I slowly crack these and, keep my fingers and everything away from it and keep a rag. Saw some fuel squirting, and there's gonna be some fuel leakage. That's normal. Seen some very wild injuries happen when opening up high pressure fuel systems. Just be careful with it. Take your time. You know, once pressure is released, you know, you're okay, but you want to get that initial release without putting yourself at any risk. So you have that released. We have a little bit of a bracket here that holds on to our fuel rails. These are held down with E6 Torx, so I'm gonna go ahead and take those off. So you can go ahead and remove the high pressure feed line. More fuel is bound to leak out here. Put this off to the side. And now from here, we can undo the feed line into the high pressure pump. This is the low pressure side, so a little bit less concerned by this. Expect more fuel leakage because all right, next up, we're gonna get our high pressure fuel pump out. This is held in with T30s. I'm gonna go ahead and move it a little bit at a time. So basically I'll loosen the one screw, loosen the other, and walk it back and forth. The high pressure fuel pump is gonna be under spring tension, and I don't wanna just take one screw out and then have it get, you know, cocked in sideways because it could damage the high pressure fuel pump. This has the updated screws on it, which have the thread sealant. When we go to reinstall this later, we're gonna put new screws in with thread sealant. That way oil doesn't come up through the threads. So this bolts directly to the cylinder head. And while we're here, take a look at the cam follower for the high pressure fuel pump. These are generally not problematic, but yeah, I mean, I guess there's some wear on there, but nothing to be really concerned about. And the other thing too, when we go to reinstall it, we'll move the engine over so that the follower is at the lowest possible position. That way we don't have to fight to get the high pressure fuel pump back down and on. So right now it's at a pretty high position, which is why there was a lot of tension on the fuel pump. We'll go to reinstall it. We can go ahead and set it at a lower position. And that'll be easy to do, especially with the valve cover off, because you'll be able to see where that follower is. And yeah, just easier to do it after the fact. It's kind of guesswork up front. All right, from here, we have this part of the engine harness, which we need to kind of move out of the way towards the front of the engine. It is secured to the valve cover itself. So these are just kind of locked in place with some tabs. Just pull those tabs open, and then you could slide it up and out of the way. Another thing I'm just gonna do, you can probably get away with leaving your air box in. I'm gonna remove it just so you can see what connections you have to do undo from the front of the engine. And if you are gonna take the air box out, it's pretty straightforward. Just gonna loosen that one hose clamp, take our hood release cable, and take the air box, and we're gonna pull it up off its mounts, like so. And it'll give us a little bit more access to the front here because we have to take the breather off. You don't, like I said, you don't need to do it, but for us here in the video to show you what you need to undo, it'll be a little bit easier. So here at the front of the engine, we have our crankcase vent hose. This goes down to our inlet hose for the turbocharger. So this is your fresh air suction hose going in. We need to undo this little tab here. This is actually missing a tab, so we're probably gonna replace this hose to put it back on. But there's two tabs, just press those open, pull them off. There's also an O-ring here, which we're gonna look to replace as well when we put the valve cover back on. Now we have our Vanos cam magnets, if you will. These actuate the Vanos gears. These have to come off, or we have to disconnect these to pull the valve cover off. So we have our little electrical connectors here. Little release tab is down there, and then they just sort of slide off. All right, so at this point we have our high pressure fuel rail that we are going to want to disconnect from the fuel injectors. So just come in here with a these adjustable plier wrenches. These are 14mm flare nuts, if I recall correctly. There are special sockets for, you know, these high pressure fuel connections. At this point, there is no pressure in the system anymore. It's just going to leak fuel, but fuel evaporates. Also, these should not be that tight. It's very easy to break these nuts if they are over torqued. So when we reinstall them, we will do it properly. These are totally fine. I mean, these are tiny little wrenches and they came off, but I've seen a couple of these where it's just insanely tight and they should not be. From there, I'm going to take the high pressure fuel rail out of the way. You could technically pull the valve cover without having to take the high pressure fuel rail off the valve cover. My only hesitation in doing that is if you don't pull the valve cover off perfectly square, the seats of these fuel rails could get stuck, or these little fuel feed lines off the main rail could get stuck in the injector, and then you can bend them, which is not really worth the risk. Just a couple of E8 screws that holds the fuel rail to the valve cover. I'd rather do this than have to worry about replacing a high pressure fuel rail. So up to you as to how you want to proceed on that, but I think it's safer to do it this way. I'm going to disconnect the vacuum pump here at the front. This is, you know, for the brake booster. And then we have 3 T40 Torx screws that hold this to the back of the cylinder head. We have one all the way down here at the bottom. Crack that loose. I have these really, really stubby Torx sockets from Vim Tools. We do carry those at FCP Euro. Really helpful for this, but also if you have like one of those 1/4-inch bit drivers, you can use one of those as well for this. But you need something very shallow because you just don't have a lot of room behind the engine for this. Fortunately, once you get these bolts loose, they come out very easily, and that's the one positive. Now you just simply pull the vacuum pump out from behind. And again, early production car with the pneumatic wastegate, so it has this additional vacuum hose attached to it. You're not going to see that on the later production. And just as a safety, I'm going to pull the Vanos actuators off. It's held on with, they're both held on with 2 E6 Torx sockets. These push on the plungers for the Vanos hubs to you know, either advance or retard cam timing. Technically, you don't need to take these off to pull the valve cover, but this is kind of a similar situation as to the high pressure fuel rail. I prefer for these to be out of the way so that there's no chance for anything to get snagged. You know, it's not too much additional work to take these off. These are agnostic between both intake and exhaust, the exact same parts. So these happen to be labeled. That was for a video that was done a long time ago on this car, which was the N20 timing chain replacement. But it's just this little thing right here. I just don't want that to potentially get stuck on that. I just feel better with them off, that's all. All right, now from here, we have access to all of the E-Torx bolts to pull the valve cover off. So we'll start from the middle, we'll work our way around the perimeter, pull the valve cover off, and that'll give us access to the top of the cylinder head. So we have a series of E10 Torx screws, both internally and externally, that we need to remove. So I'm just going to start on the inside and work our way towards the outside. These are supposed to be encapsulated to the valve cover. However, given the age of this valve cover and the condition that I'm seeing, I do expect some of these to possibly come out entirely. Like basically the sleeve will end up coming out. And if that happens, we can put it back in or replace the valve cover, which may be a better choice. All right, all the screws should be loose, so I'm just gonna slowly lift up on the valve cover. Have to break the seal. If you're lifting the valve cover up and it's not breaking free, you might still have a screw that's a little bit still stuck on some threads, or maybe you missed a screw. But you want to be careful when you're pulling it up because it is plastic, clearly, and it is a very easy part to break if you don't show a little bit of mechanical sympathy. But these are all the screws you have around the perimeter. There's really only these two in the back that are slightly obscured. It's fairly easy valve cover to get off though. All right, so our next step here, we need to remove the injector hold downs, which are right here. So it's just two 10mm screws. If you look at it from the side, you can see how it's kind of bowed down a little bit. When you torque this down, it does compress the injectors into the head. So we're using the CTA 7658, which is an injector puller specifically for N20s, N26s, S55s, N55s. You know, sometimes you can pull these injectors out without the puller, but this does make sure that they come out evenly. You don't really want them to move side to side when you're pulling them out, especially if you plan on reusing them. Yeah, so you can see the reason why this was stubborn coming out is there's quite a bit of carbon right around the tip of that injector. So we might be able to clean that off. Looks like possibly looks like maybe the seal was compromised at some point. Because you see this side over here, it's very clean. And then over here, it looks like some gunk, some carbon made its way up to the seal. So now that we have the injectors out, we can pull our these injector wells out of the cylinder head. We obviously have to do that because here's our Valvetronic actuator, and that is tucked deep down in this crevasse, which is blocked off by these. These have to be removed no matter what. So we got two T30s, that's all that's left, that's holding these in. There's a total of 4 fasteners that secure these injector wells. 2 of them we've already removed. Those are the hold downs for the injectors. So, and there's a gasket that seals these to the cylinder head. So right here we have a little oil squirter. This lubricates the worm drive mechanism here on the motor and the eccentric shaft. This just, we're gonna have to move it out of the way no matter what. And also on N55s, I know that these sometimes have a tendency to clog up, which could cause eccentric shaft wear. Again, have not heard this being an issue on N20s. With that said, we'll go ahead and drop this thing into some carb cleaner overnight and let it soak and basically clean it up. Could replace it, but you know, I'll come to that conclusion of what it looks like and if that's even worth doing. So now at this point, we can move the eccentric shaft via the 4mm drive with an Allen key. A 4mm long Allen socket would be preferential, just because you really need to make sure that as you're doing this, you do not lose grip. This is spring-loaded. There are points here where you can support the eccentric shaft, and that is recommended to do, just because if you were to lose grip of this thing, it will yeet itself into a stop, whether it's on the high side or the low side. Because again, you're fighting the spring tension here for these intermediate levers. What we do need to do though is we need to remove these stops. These are both the max and min stop limit for valve lift or for the eccentric shaft travel. And what we're gonna do is, in this case, we're gonna come over here, which is gonna be minimal lift. I wanna kind of show you this procedure. Because as I bring it down to the stop limit, that is our minimal valve lift. So right here, that is the minimal lift stop, and this is the maximum lift stop. So there's 2 stops, and you can see where the eccentric shaft has touched before, because there's like this little dot. So that's a mechanical stop. We need to remove the stop in order to disengage the eccentric shaft from our Valvetronic motor. Because you can see like it's still engaged. You can't just unbolt this eccentric shaft actuator without removing these stops. So what we're going to do is, I have this 4mm Allen here. You just simply kind of come down this hole. That's normally where the oil squirter would be lubricating this interface. And all we really need to do in order to accomplish this is just remove this stop minimal lift side. So to accomplish that, there's two areas that you can support the eccentric shaft from. You could do it up here in the front, or you could do it from the back side. I'm gonna do it from the back side, and this is just to make sure that if I lose grip of the Allen, I don't let this thing just slam into a stop limit, which could potentially damage the eccentric shaft. It's recommended that if you're moving this, that you do support it at the same time. It's also gonna make it a little bit easier to do so. And as you're moving this, you'll feel the spring tension build. You do get it to a point though where eventually the spring tension kind of eases. I'm gonna hold that there. I'm just gonna move my wrench and we'll bring it all the way up here to the max lift, and we'll let it sit on the max lift stop limit. Once we get it up there, it'll be safe to let go because it can't roll back. There we go. And if you have a shorter 4mm Allen key, you can take it and put it in a way that wedges it against the body of the Valvetronic actuator, so it can't possibly roll back. But again, once you have it at that max lift position, it can't roll back on its own. Using 11mm socket, we're gonna go ahead and remove this stop limit right here. And you'll understand why this is important in a moment, because again, you can't disengage the eccentric shaft from the Valvetronic motor without being able to rotate it past the engagement point. And this is all it is, it's just a little stop. And you can see the witness mark from where the Valvetronic shaft stops against it. So now we're gonna come back the other direction. It's just a worm drive gear, so it's a pretty simple mechanism. And we're gonna let it start coming back. Again, we are supporting the eccentric shaft. We don't want this thing to just go flying, especially now that we've removed the stop. So we want to support it as we're doing this. And now that we have it in that position, we'll go ahead and remove our max stop limit. And if you compare them, these are the same. So you don't have to worry about potentially mismatching them or putting the wrong place. They're the same length, same height, same everything. So, and again, you can see the witness marks from where the eccentric shaft stops. Acts as a maximum lift point. And now we will rotate our eccentric shaft again, but this time we're gonna do it so that we can disengage the eccentric shaft from the eccentric shaft actuator. And again, as we're doing this, we're gonna support the eccentric shaft itself, particularly now that there is no stop limit. We don't want this thing to just go freaking flying. In this operation, the worst thing you can do is basically damage the worm drive gear on the eccentric shaft. If you were to do that, you're buying a new one, which is additional work and repair to replace. So, you know, you can avoid that. That's always gonna be a preferential thing. And that's why you wanna support it, because once you disengage it, it wants to just, so again, holding on to it with a pair of wrenches, it's a little safety thing. And even holding on to it, you can see once it go, it wanted to just, so. Right about there feels pretty good. Feels nice and neutral. And now all we have is 3 10mm screws to take out, and we will have the actuator out. And what we can do is just spin the motor around, take a look at the splines on that, see if we see any kind of crazy damage or wear. I don't really see anything horrendous on that. I mean, you do see some wear, because this thing is always moving and adjusting. And as this spins, clockwise or counterclockwise, it either increases or decreases the lift, which, you know, changes engine speed, engine load. Yeah, this right here is your throttle body. But, and again, like I said, this sits pretty deep. We have a oil lubricated ball bearing. Here's your permanent magnet motor right here. Something was magnetic at some point, but this is a very torquey motor. And considering this sits inside the cylinder head and goes through numerous, you know, tens of thousands of heat cycles, at least in this car's case. I mean, 200,000 miles. Pretty impressive, all things considered. All right, so now we're at the point where we can install the new Valvetronic actuator. So right now I just have the eccentric shaft sitting in a rested position against the minimum valve lift stop. I need to rotate it up so I can take the stop out. Then when the stop is out, I can move the eccentric shaft into a neutral position, put the Valvetronic motor in, and start putting the stops back in. So again, you know, we need to support the eccentric shaft, critical. All right, so I just moved the eccentric shaft back over to its most out of the way position. I really just need the gear, the whole gear, to be that way. And now that it's on that side, I'm gonna reinstall our stop limit on here, because what I can do from this point is reinstall the Valvetronic actuator, slowly move the cam back over while I'm rotating the gear, and then it'll gauge, and then I'll be able to pull it into position. We're gonna torque the stop limit here to 10 Newton meters. It's 11 millimeter drive, but it's a 6 millimeter thread. In fact, most of the torque specs on this job are gonna be 10 Newton meters. So just be prepared. Want to make sure that the drive interface between the motor and the eccentric shaft is greased. BMW does have a lube for this, but we're using some Liqui-Moly Litho HT50. It's just a lithium grease. You know, once the oil squirter is spraying, you know, it'll be fine, but this at least provides lubrication on the initial use of this, which is you don't want any kind of dry surfaces on this because that will cause excessive wear. The gear on the drive motor is definitely harder than the eccentric shaft material is. So, and I can tell you which one is more expensive. It's the eccentric shaft. So you don't want to replace that because it ran dry. So we can just place the motor in like so. We'll get our mounting screws for it. Now we put the 4 millimeter Allen into the Valvetronic motor so that once we start rotating the eccentric shaft back, we'll be able to engage the eccentric shaft with the actuator. Now we can reinstall our maximum lift stop limit. So we had the oil squirter submerged in some Liqui-Moly fuel additive last night. Want to make sure that, well, that and the injectors, all the carbon had been cleaned up. There's obviously a yellowish tinge to this today. So I'm just gonna make sure that there's a clear passage. Oil squirter is clear. I don't think it was clogged before, but like I said with these, if the engine is super dirty, and this one is, there could be a tendency for carbon to potentially build up on the inside of here, and then you don't get proper lubrication, which will then cause the eccentric shaft to wear out, and then you're replacing the eccentric shaft. You don't want to do that if you don't need to. So just let it sit, let it soak, cleaned up, removed a lot of the varnish actually, and the same thing with the injectors. We had a bunch of carbon on the tips. This did a pretty decent job cleaning it up, so that is a nice little thing you could do if you were so inclined. In this case, we're waiting on some parts, so we had some time. All right, we're gonna just put the oil squirter back into position. So the oil squirter is supported by this little bracket here on the Valvetronic motor. Just wanna make sure that it is seated back into position. We'll reinstall this E8 Torx, and then we will torque it to spec. What's the torque spec for that? 10 Newton meters. All right, we're gonna go ahead and take our new gaskets, place them on the cylinder head. They're gonna sit on the dowels, so you don't have to worry about supporting them. They'll pretty much just stay in place. I did take a shop towel, a little bit of brake parts cleaner, wiped off any oil that was on the surface. I also did the same with our injector wells. These are not specific to location. They're the same for cylinders, 1, 2, and 3 and 4, so they can go back anywhere that they were before. Doesn't make a difference. There is a total of 4 screws that hold the injector wells to the cylinder head. 2 of them are on the outside, and then you have these 2 here, which are used for the injector hold down. When we go put the injectors in, which is gonna be next, that will resecure the injector wells back to the cylinder head entirely. We're at the point right now where we need to start reinstalling the fuel injectors. To do that, we need to put a new compression seal on, and it's also a good idea to put a new decoupling element on as well. So what we have here is we have an injector seal cutter. This happens to be the BMW specific tool. I like this one the best. Some of the aftermarket options are not as nice. I'll show you why this works really well in a minute. But you know, if you get it, it comes in this nice white box, and it comes with a little thing for your drawer liner, so you can always put it back in the same place. You know, again, had these injectors sitting in some Jectron, I mean, it just melted the carbon off. I did notice that, you know, there was quite a bit of carbon on the tips of these. This thing was not running very well, so I wanted to give these injectors the best chance possible to have a good shot at performing well. Just gonna pop off our little decoupling element here. This kind of acts as like a vibration damper against the cylinder head, so you don't have metal to metal contact between the injector and the cylinder head, because it could potentially oval out. And you know, if you look at them, there's a tiny bit of compression on these compared to the new one, so that's why it's recommended to not reuse them. From here, I'm going to take our injector cutter, and as you can see, the injector kind of sits in there, and it's going to do a nice glancing blow against the Teflon seal. And then from there, sometimes these things can be kind of tough. Might have to nick it more than once. There we go. Nice and easy. Some of the aftermarket cutters are more generic Teflon seal cutters that I've seen out there. They don't do a good job of cutting through it. They try to cut directly through the top of it as opposed to going through the side. So this is one of the better options in my opinion. And the factory tool is really not that expensive. Definitely cheaper than putting new injectors in, I can tell you that. And now from here, we have our new seal. So we're gonna take this mandrel, and we need to start pushing the Teflon seal up towards the edge. This is going to expand the seal, because it would be impossible to get this on the injector otherwise. So we're gonna take that, put it on the tip of the injector. That'll allow us to get the injector to slide on. Drop it down to where it needs to be. And then we have 3 mandrels here. Order of operations is this one first. We just kind of walk it down. And the whole point of these mandrels is it starts to compress the seal back to its original size. So I'm gonna put this one on here for like about 30 seconds, because what happened is this mandrel just spreads that seal out so it can get over the injector tip, and then it needs to be squeezed back down to its original size. And Teflon is pretty tough stuff. So now there's a different type of compression tool that's available for these HD EV5 Bosch style injectors. We'll provide a link to the BMW tool. This is also a BMW tool, but these are for N54 seals. Effectively works exactly the same. This is a little bit more of a manual process, but you're gonna have more access to these style tools out there as opposed to the more Bosch specific tools. That's the last mandrel. We're gonna let that kind of squeeze for about 30 seconds, and then it'll be ready to install. We already did this with this injector, so you can see the seal gets back down to its normal shape, or where it was before. And when I pull them off, I rock the mandrel a little bit side to side. I don't want to just pull it, because it can have a tendency to pull the Teflon seal with it, which you don't want. You just want it sitting right there where it's supposed to, all proper. We'll take the new decoupling element, slide that on. We'll just click into place. And this injector is ready to go. So we've already done bank 1, or well, cylinders 1 and 2. And now we're just gonna do cylinders 3 and 4. And after these are in, the injectors will be installed. So I did number these injectors, by the way, 4, 3, 2, 1. So the injectors are going back into the exact same place they came from. When you go back in, best thing to consider is where our connector is and the hold down. So the hold down here is square. They need to stay this way, and then the injectors are going to face back towards the middle. Another thing to consider, you really don't want to rock these injectors side to side. Cylinder head's aluminum, and you know, if you do enough of that side to side motion, you could potentially oblong the injector hole, and then you have to fix that, which is potentially nerve-wracking repair. So I just try to get these in square, and then I use the injector puller to seat the injector back down, because it's also an installation tool. The point is to get it back in the bore as square as possible. And if in doubt which way it needs to go, if you're looking at the part straight on, you'll see it like bow down a little bit, and the bridge, or where the bolts go in the middle, the high point needs to be towards the middle, and then the square cutout where the injectors are retained, that's gonna be the low point. That needs to be towards the outside. You don't want to install it upside down, because then it's not acting as a spring, and the injectors will eventually become loose, and then you'll be very unhappy. So I'm gonna go ahead and tighten down the retainer here. There's a stud bolt, and then there's just a normal, or stud screw, and then a normal. The screw that has the stud needs to stay up towards the top of the injectors. Remember, that was the grounding point for the ignition coil, so it needs to go towards the top, and then the normal screw goes towards the bottom. Use your 10mm drive. Now would be a great time to replace this valve cover, but we're not gonna do that. Reason is, we're doing some other additional product testing on this car. Saw how dirty the cylinder head was. We're gonna try some flushing, and we're gonna put a different valve cover on once we pull this valve cover back out to see what it looks like. So if you're looking at this and you're asking why are you putting it back on, technically this is functioning totally fine. It is dirty. It would actually be beneficial to put a new one on, but there's no problem with this one, so we're gonna go ahead and reuse it for now. We got a new one here that's gonna be going on after. We're gonna get rid of the eccentric shaft actuator gasket, or the Valvetronic actuator gasket. I'm gonna put this on only after this is installed, and that's just to make sure that it doesn't get pinched on the valve cover when we put it on. So these are nice because you can replace them independently of the actuator. So if you did notice a little bit of oil seepage around the connector, you could just replace this part and move on with your life. Underneath, we have our spark plug recess gaskets right here. These come with the valve cover gasket set. We will not be reusing these, as you shouldn't. The gasket itself, is there a good peel point right there? Now, here's a point to grab from here, and there's a point to grab from here. You're gonna match the new gasket to that. That way you can line it up, make your life a little bit easier. So there's like a little area for the nub to stick out. The nub that I'm referring to is right here. So you're just gonna look for that and line it up. And then the last thing we need to get rid of is our vacuum pump gasket coming from behind with a screwdriver. And hopefully just pop it out like so. Full aggression, no hesitation, zero sympathy for the plastic valve cover. And I'm just gonna push the new seal in like so. They come out pretty hard, but for some reason they go in really easy. I don't know. So there's a nub there, there's another nub there. And this should be going over here. So it's a pre-molded gasket, so that means it can only go on one way. And those little alignment nubs I was telling about, that is so that you can actually install this gasket the first shot. So just look for those little alignment nubs on the gasket, and then you're just gonna lay it in like so. Work your way around the perimeter, get it fully seated. Working my way around, making sure it's seated the way that it should be. And you know, if you feel like you're putting the gasket in and it's kind of going in kind of strange, or it's not lining up 100%, just keep working your way around the edge. Once the entire gasket is seated in the groove, you can kind of like push it around and get it to do what you want. So we're good from that front. And we have a similar situation here for our recess gaskets, although these are a little bit easier to look at visually and understand where they're supposed to go. So again, they do have like this little nub that's going to stick towards the inside. So you're going to look for that recess on the valve cover, and you're just going to go ahead and lay them in. So right here, here's a nice little open area. Here's the nub, it faces down. Just go ahead and all right, that O-ring is seated, and then we just have these parts left over, which we're going to be installing once the valve cover is on the engine. So with that said, this is ready to go. Let's go ahead and get on the car. All right, so I already cleaned the outside edge of the cylinder head, just took a rag with some brake parts cleaner on it, just ran it around. Now we're going to go ahead and place the valve cover back down onto the cylinder head. I want to make sure that it doesn't touch anything on the way down or dislodge the gasket. It's really the only thing you need to be careful with. But you should have plenty of room to get it into position. You have, for the first time, a different torque spec than 10 Newton meters. It's 9 Newton meters, even though it's the same thread size. So a couple things to note: when you go to put the vacuum pump back on, you might find that you're gonna have to finagle with it a little bit. The best way, in my opinion, to get it to line up is don't touch the engine at all. Don't rotate the engine, leave it alone. So you don't have to realign the vacuum pump with the drive mechanism on the back of the cam. If you happen to move it, what you can do is you can either align the vacuum pump before you put the valve cover back on, or just generally feel for the alignment of the little nub that it has to engage with, and then rock the vacuum pump back and forth until it finally engages and drops in place. And once it drops in place, I'm going to tell you, it's one of the most satisfying experiences, especially when you're doing it blind and you can't see it and you're just like, damn, I'm good. You know, it's those little moments, you know, those little W's that you get from time to time. We'll plug our vacuum booster hose back in, or brake booster vacuum hose rather. All right, next up, I'm gonna go ahead and install our fuel rail. Take our little covers off the injectors, start to reseal the fuel system, which is generally the thing that I would say happens more often than not. You run the risk of actually cracking the flare nut, which will then cause a huge leak. The only thing the nut does is it keeps the flared line into the inlet of the injector. It's not to seal it. The male flare and the seat on the injector, the female seat, that is what creates the seal, not the tightness of the nut against the injector. So I'm going to take our Valvetronic actuator seal. So you notice that the high pressure fuel pump just dropped down into position and we didn't have to wrestle with it. That is because I did bar the engine over by hand. So I made sure that the cam follower was at the lowest possible point so that we don't have to sit here and force it to go back down or rock it back and forth. If the high pressure fuel pump has never been off, there was an update on the screws. They have thread sealant on them. So make sure that you order the screws with the thread sealant, or if you were using the original screws, make sure you apply thread sealant to them. Before we get too far ahead and reconnect the fuel line, I'm just going to make sure that our ignition coil and fuel injector harness is sort of latched back onto the valve cover. If we put the fuel feed line in before we do this, we just won't be able to put it back in place afterwards. So, you know, I'm just going to do this now. You'll just hear it kind of click in like so. I'm going to leave this kind of loose up front. We still need to put the Vanos actuators on. Actually, we'll do that now. And these just go back into place. They're the same left and right. No part number difference. Word to the wise, if you happen to replace the valve cover Before you throw the valve cover in the trash, make sure the Vanos actuator seal is not stuck on the inside and it's still on the Vanos actuator, because if you're in the trash, going to put the valve cover on, the seal's not there, you cannot replace the seal. You'd have to buy a whole new actuator, and that would be an unnecessary expense, given that these are fairly reliable and not failure prone. So plug the connectors back in. Take our fuel feed hose and bring it back up to the high pressure fuel pump. So at this point, we got the bracket on the back of the valve cover. Most of the electrical connections are back to where they need to be, but we just need to run this fuel line from the high pressure fuel pump over to the fuel rail. Flare nuts here are 17 millimeter. And then remember, this is a pneumatic wastegate car, so we're going to put our wastegate control solenoid back into position. We'll also plug our connectors back in for the injectors. Push them down until they click in place. All right, so I'm gonna go ahead and put the airbox back on. We're gonna start the car here in a moment. Of course, like I said, the airbox did not have to come off to do this job. We just simply removed it for the sake of being able to see things at the front of the engine better. So I'm just gonna slip this back on. Tighten down this hose clamp here. It's a 6 millimeter drive, so if you have like a hose clamp driver, that's the size you would want, or a flathead or a 6 millimeter socket. You do what you want. So this is where the pneumatic wastegate cars are kind of dumb. I do want to start the engine, make sure there's no fuel leaks or anything like that, so I do need to hook up the wastegate actuator. I'm going to do it with the engine cover kind of lopped off here to the side. It's kind of awkward. It's not a great design. Really wish it was not integrated into the engine cover, but you know, it is. And the vacuum line really just popped off, so that's great. So again, silly pneumatic wastegate car with the canister built into the engine cover. I have to let it sit on top just to start it, make sure there's no fuel leaks, but we're gonna fire it up, give the throttle a quick blip, but we're gonna see how it sounds. You know, if it sounds good, it's not misfiring, we're gonna probably call it a win. But I'm not gonna put everything back together until I know everything is good, at least at the engine, so. So great news, it started and it runs and there's no fuel leaks. Burning oil like crazy because of all the stuff that fell on the exhaust manifold, BMW problems. So at this point, just need to go ahead and put the reinforcement plate back on and all the other stuff that we took off to gain access to the engine, and put the engine cover on last, hook up, you know, the pneumatic lines, and good to go. So just go ahead and put this back together and see you briefly. I'm not gonna explain how to do this because if you made it this far, golden at this point. So aside from a couple oil drops from the engine cover, because of the stupid vacuum canister, so that's how you go by replacing the Valvetronic actuator on an N20 powered BMW. Obviously worked on an F33 series, so depending on what chassis you have, it's going to be a little bit different, but overall it's a fairly straightforward process. One thing you will need to do at the end of it is if you did have a permanent failure, you're gonna have to do a relearn. You could do that with ISTA, any kind of scan tool. It is recommended to do it. Sometimes the car can relearn on its own and the fault code will go away. But without that relearn, may not run properly right off the rip. The relearn procedure is recommended, so definitely follow through and make sure that's taken care of. You could possibly drive the car to have somebody do that for you. But with that said, fairly straightforward process. Hope you learned something. If you have any questions or comments, leave in the comment box below. If you like this video, hit the like button. And as always, hit subscribe. We have a ton of videos on the way, and we'll see you for the next one. Thanks for watching.